Hello, my name is Tobias Heiler and I'm one of the founders of BrainBoost. In this webinar, we will show you how you can now use live Z-score training in the BrainAssistant. We will show you what pre-built protocols we have, but also how you can create your own Z-score training protocols. Doing that, you can choose what position you want to train and also what frequency bands you want to train with Z-score trainings. Have fun with it.
Let's get started. So thank you for being here, for attending the webinar. As always, we're always continuously connecting new devices and also working, of course, on talking to other manufacturers. So if you know somebody, feel free to share the contact with us. So today's topic is Z-score training protocols. So there's a prior webinar where it's about, where we talked about Z-score generally, Z-score analysis, and this webinar is about using Z-scores to train a brain. So first, a few words about Z-scores in general. So Z-scores, or also standard deviation, so SD is the short version for it. I'm not going to explain them in depth right now. So the other webinar, I explained them quite well, as deep as I think as you will have to know them. The basic idea still, let's take a few minutes. The basic idea about standard deviations, so Z-scores, is that I have always the same units, standard deviations, to determine if something is within a, I would say, population, a standard range. So as we can see here in this curve, we see that there's a 68%, so 2/3. So I measure something. I will come to examples. It can also be brain activity, of course. And then I determine, okay, I'll take out of the entire samples, all the samples I took, I take 2/3 of them and say, okay, plus and minus 1 standard deviations means you are within this, well, 2/3 of this population, what I measured. And if we then continue towards the sides, then there's almost everybody, so more than 90% within these standard deviations. Example, I'll take body height, or I'll take income, or a weight of a car. So let's say I walk around and I measure all the cars that I can find and say, okay, let's take an average of all the cars I measured, and they weigh 1.5 tons. And so let's take the amount of plus minus kilograms. So I get to 2/3 of all the cars I weighed. So I say, okay, to get all cars that I measured, 2/3 of them are plus minus, let's say 300 kilograms. So 1.8 tons would be here. And then 1.2 tons would be here. So when I say I have a car that weighs, for example, 1.7 tons, a person that doesn't know anything about cars cannot say, this is a heavy car, this is a light car, I have no idea. But if this person knows what Z-scores are, you can just tell the person, my car weighs 0.2 or 0.3 standard deviations plus. So you know, okay, this person has a car that is within a normal car of this population, very important, of the measured cars. So a little bit heavier than most of the cars, but kind of a normal car. So the same with body height. So if I walk around, measure people, and then I say, okay, I know a person that is, you know, minus 1 standard deviation tall, then I know, okay, it's kind of on the taller end of 2/3 of all the people, but it's not a super small person. Or, you know, if I have a person that is plus 5 standard deviations here way outside, then this might be a basketball player, so a person that is very tall. So I don't measure stuff in centimeters or tons or degrees Celsius or whatever. I rather say, okay, I can always orientate myself. Is this within a normative range? I know with brain activity, norm is a word we got to be careful about. And now, of course, a huge, well, factor we need to pay attention to is, what is my population? What do I refer to? So maybe when I say, you know, I know a person that is 5 standard deviations tall, I said it could be a basketball player, but what if I I only measure basketball players? So then a person that is maybe, I don't know, 2 meters tall would be exactly, let's say, 0 standard deviations tall. So the same goes for car weight. So if I just measure super light racing cars, then of course a car with 1.7 tons weight would be way outside here. So same with body height. If I include, you know, children, if I include small people in different countries, it always means where do I set the limit of this is my normative population, or this is what I want you to what I want you to compare to. So this is very important. Also, especially with brain activity, I will come to that point. Also, here, this is an example for theta, brain activity, +2 standard deviations. So here I would say, okay, if somebody has +2 standard deviations theta, and we know this from the report you can generate with our software, that it gives you these brain maps, the heat maps, and shows you are you in a plus or minus range compared to a person within your age and your gender. This and eye state, eyes open, eyes closed. This means, oh, there's a lot of theta going on. But of course, compared to, or the difference between a live Z-score training and then a report is, in a report, we have a mean value over a certain time. So for example, 3 minutes, eyes open and eyes closed. But of course, it can also look like this, right? So I can also, have theta within ±0.5 to 3 standard deviations. So this is going to get interesting when we do a training for Z-scores, that it's not always, it doesn't mean that I'm always 0.2 and I'm kind of just fluctuating around, I'm always +2 standard deviations. It can be a huge variety of theta going to plus and minus. So I will get to that point. How can we make sure that it's not like a extreme behavior of the bar we are training with? So let's, I would say, jump right into practical exercise and take a look at the functions in the BrainAssistant. So here we are. And first of all, you should all do an update to make sure that you have all the available Z-scores. Also, another important factor, I'm just going to check this here, is that you make sure, exactly perfect, that you make sure that you always enter the correct gender and age. In this case, my demo person is 13 years old. And if you get this wrong, then of course I compare you with people with a different age, so it doesn't really make sense. So let's start a training session, set a protocol, and start here. So this is a view you're all used to, so we can train with amplitudes or frequencies, so frequency bands. Now, I can, of course, say a person with a high lack of concentration, so focus problems, will probably have a lot of theta, maybe alpha activity. If somebody is in a very stressful situation, you will have a lot of high beta. So I want to train this, inhibit or reward this, depending, what I want to train. So here I know exactly what's the absolute level of theta. Is it, 18 microvolts, or is it, how far is it increasing, decreasing? Now, a different approach would be here in the top right to go into Z-score neurofeedback. Let's go here. We also have some pre-built protocols, as you can see, and you can also configure your own protocols. Now, very important, if we work with Z-scores, I would not take just one single position and just train one individual frequency band. So if you say, I'll just take ZZ and only train theta, then I will have this problem. The bar that you're used to from amplitude training, so theta bar, for example, is a little smoothened, goes up and down. But if I say, okay, I want to train exactly that you're within, let's say, 1 or 2 standard deviations, so either outside the corridor or inside, that you will only have one bar that jumps up and down. So you're in or you're out. So we will take a look at this from a practical point of view. So just something you will have to pay attention to is if you just train one position and just one frequency band and say my cutoff is you need to be within, let's say, 1.5 standard deviation. So let's get closer to the normative database. Or if you're outside, this is bad, I give you a negative feedback, then just make sure you're either in or out. So this will cause a very jumpy behavior of the bar graph. So don't worry, we thought about this. So first, let's enlarge this. So first, very important, it makes sense with a Z-score training to use a higher amount of positions here and a higher amount of frequency ranges, so frequency bands. So there is not an either or situation occurring if you're in the corridor, yes or no. So it might get a little jumpy. This is what we predefined here for you. So why does it look kind of double in this case, or not kind of, it looks double. We of course need to pay attention, close attention to the eye state. So is it eyes open training or is it an eyes closed training? The rest here, as you can see, we defined, and these I will show you how you can create your own protocols. We defined as eyes open trainings because usually most people don't do an eyes closed training, for example, for frontal areas. So if you have problems focusing, for example, then an eyes open training is recommended anyways. Rather, of course, these are very general statements. So strong recommendation is to use at least 3 positions and more frequency ranges. So we are at more than 20 parameters. Parameter means positions multiplied by frequency ranges. So 3 times 9 equals 27. So obviously 11 times 9 is 99. Let's take a closer look what I just talked about. So we can create a new Z-score training protocol. This now gets interesting. So maybe some of you already worked with Z-score training protocols. So first we can define, let's start with this one. I will explain this graphic in a second. So EG positions. So as I said, we should go minimum on 3 positions. And frequency ranges, I would strongly recommend to take at least 5, something like this. Of course, it kind of depends. So if we're here now at 1, 2, 3, 4, 5, 6, 6 times 3 is 18. I would see that I would try to get at least to 20 parameters. Now it gets interesting. So now I kind of mix them together and say, okay, on these 3 positions times 6 frequency bands, I'm either, let's make this a 0. I'm either within 1.5 or outside 1.5 standard deviations. This is what I said, when you just have 1 position, 1 frequency band, it will be very jumpy to set the threshold bar with the reward threshold. Now, what we designed is that I say, okay, I don't want an either or, and I will come to the mathematical or the math behind it with another slide. So just pay close attention, I will explain it. I can also say, let's give everything a little bit of a smoothing. So let's say, I don't want to tell you you're either in, this would be the 1. So you count the weight of an individual and the weight, let's make this simpler, the weight of an individual frequency band, in this case, theta of C3, let's say, is inside, ZZ and Z4 is outside. So the weight of C3 would be 1, so 100, and the rest would be 0, 0. So maybe I say, 1.5 is a very hard cutoff. So I want you to get a reward when you're kind of approaching towards the 0, and when you're moving away, I also want to be a little bit more smooth and say, okay, still you bring a little bit of a weight to a positive feedback. So if I say, for example, point, of course, if we're in the English version, we need to work with point. In the German one, you need a comma. So with a 0.3, I say, okay, I take 1.5 standard deviations as a cutoff and plus minus 0.3. So actually I say you get a weight, so a full reward, as I said, I will explain this with some graphics. So at 1.2 standard deviations, I counted 100%. The bar that fills up or lowers will be filled up at 100. If I'm at 1.5, I'm only at here 0.5, so 50% positive reward. So the bar that is from 0 to 100, like the theta alpha SMR bar, it fills up. Now it doesn't fill up with microvolts, of course. It fills up with, are you within this corridor, yes or no? And if I'm 1.8 away, then I'm just done, then I'm adding a 0. So then I'm actually outside. So with this smoothing, and of course we could go even more extreme, but this is kind of an extreme case, but you know, you can try around yourself. This means that when I'm approaching, I give more and more positive weight to the 1 bar. Am I inside the corridor, yes or no, filling up? So this is the idea behind the smoothing. What I would recommend as a default would be 1.5 and 0.3. And as I said, I will explain this a little bit more later. And of course, set the right condition. Let's cancel this. So let's take, the very first protocol. So let's say we put on a cap with a lot of electrodes and do like a general, I would say, rebalancing of the brain. select. And what is now happening? Start. What I see here with Z-score training, I will always have only one bar. This is what I meant before. Am I inside the corridor? Yes or no? So this is what we want to train this up. So reward. So we want to reach, best case, 100%. So all the set frequency bands in all the positions are inside the corridor. Of course, this will not happen unless I set the corridor at 4 standard deviations, of course. So here, by clicking, this is a manual threshold, I can set a threshold, and the value is not microvolts. The value obviously is percent inside this range. And this is what I meant with the weight I can give to values approaching the 0.5. This is where the smoothing comes in, because if I just take ZZ, just theta without any smoothing, I'm either jumping from 0 to 100 or from 100 to 0, back and forth. I'm inside, I'm outside. This is why you need an amount of positions and amount of frequency ranges, and with the smoothing here, this gets smoothened, so it's not too fast moving up or down, and then the feedback is pitch black screen or bright screen, back and forth. Obviously, we just have one success rate because there are no additional conditions. So we can just pay attention to the total success here and set the bar accordingly to whatever we like. Of course, we can also work with thresholds. If we work with automatic threshold, of course, we recommend a timed threshold with, I would say, 180 to 300 is maybe a little long, it depends. And then 30 to 45. And of course, here the aim success, since we only have one bar, would be around, let's say, 55. Also depending who's sitting in front of you with what frustration tolerance. So let's recap. The standard deviation, 0.5. Of course, if you have a person that has really values that are very volatile and like severe problems focusing, then of course that you might want to enlarge in this. And the smoothing, I will come to the next slide, gives you an example how you can not have a hard cutoff, yes inside, yes outside. And EG positions and frequency ranges, I would go for minimum 3 EG positions and frequency ranges 5. Now 3 times 5 would be 15. I would try to get to a total of 20 parameters. If it's less, if there are less parameters, then as I explained, then it just gets a little bit more jumpy. So this is just something you need to have in the back of your head and be aware of. Of course, at the end, it's your decision what you use to train. This is what I explained. A hard cutoff here would be a straight line at 1 point minus, of course, minus 1.5 and 0.5, either in or out. And with the smoothing, and this is an example here. I know, a lot of math, but let's take a look at the right side with a hard cutoff at 1.5. Let's say theta is plus 1.6 standard deviation. So right outside, it says 0, the bar that we saw here. The bar would be completely empty, 0. But then, of course, we have, in my example, we only have 3 frequency bands. Then we would have alpha with 1.4. We get a 1, yes, I'm inside. And beta would be 1.51. So it would be exactly outside. So 0. This means 0 here from theta, 1 from alpha, plus 0 from beta, divided by 3, because here these are 3 values, is equals 0.33. So this bar would be filled at 33, right? 0, 0, 1, 33. Now the idea of the smoothing means, here, yes, you were outside, here you were barely outside, and here you were just inside. I kind of want this to represent the strength of this frequency band, how far you're outside or inside. And this is where the smoothing plus minus here, it gets to a little bit of an angle. It says here in the same example, here theta 1.6, okay, so would be outside here a little bit, would get 0.33 and not 0, because it's still at least a little bit near to the 1.5 and near to the 0. So you still get a little bit of weight. Alpha 1.4 would here be exactly in, but still, I mean, it could be closer. So it gets a 0.66 because here's roughly 1.4. So it's not super close. So this is where I can, of course, decide this should be 0.1. So I'm a little bit more strict. But here, this is a good example, a bit of 1.51. I know, yes, it's just barely outside, but it's outside. And here it would roughly get 0.4999. It still is pretty close. So I want this to be represented. So in this mathematical example, I would take these three numbers, add them, divide them by 3. And this would be 50%, filling up the bar 50%, not just 33%. So the idea of the smoothing is I am pretty close to 1.5, but I'm not super, super inside. So we also weaken the 1.4. So it's not completely there. This is why it's plus minus 0.3 and not just plus 0.3. So this is the idea behind the smoothing. So I'm really representing, is a number really getting close to the 0, or is it really getting outside, or is kind of, is it like barely inside, outside, getting there. That's the idea behind the smoothing. And in our experience, the 0.3 plus minus 0.3 makes sense. But of course, you can play around with it, or you can also say, no, this needs to be 0. I just want it at 1.5, which is also fine, of course. So you have a lot of factors you can play around with. So the standard deviation, this is pretty crucial. I mean, you can do a report, check it out, or you can also gather some experience using it. The standard deviation smoothing, number of positions, number of frequency bands, play around with it, but one position and only also just 3 frequency bands will be very, cause a very volatile behavior, jumping back and forth quite a lot. And so the total parameters, I would recommend more than 20. This might be is a good idea. And then the eye state, of course, is super, super important. Eyes open or eyes closed. So when you switch within a session, you of course need to switch the eye state. This is super important. It's also stated here, Z-score EO for eyes open. So you know what you just selected, what protocol. If you have less positions, by the way, than these, it will just use the rest that is still there. Yes, and if you use here the prebuilt protocols, they're pretty useful, I would say. Of course, you can create your own. I showed you how to do that. But of course, a larger area and like a general rebalancing of the brain. This is where I see a good approach for Z-score training, but of course we're doing a lot of amplitude and frequency band training. This is a huge core essence of neurofeedback. So as always, we build and include more and more options into our training and to our BrainAssistant. And since a lot of people ask for it and we have a large amount of data in our database, we felt comfortable releasing it. So it's always up to you what protocols you use. Yes, next webinar, and of course there's time for questions, but you see today I try to be fast enough to leave room for questions. Next webinar is going to be a cool one as always. It's on the 21st of August in English, the day before it's in German, and it's going to be about Dragon Bay and a question mark update. So Dragon Bay gets an update, and you see, I know it's summer, but we are into winter. So you will get a third environment. You know, the first one, the bay, and you know, the second one, the volcano. So you're outside the volcano, and then you get inside the volcano. Who hasn't played it yet, do it. And the third one is an ice world. It's pretty cool. It has a lot of cool features and a nice looking environment. And yes, question mark. Has another game coming along. It's also very nice, and we get a lot of positive feedback on it. So it would be cool if you could join in August our webinars. Okay, then that's it for today. Take care and bye-bye. Thanks for being with us.